So my name is Marcus Smith. I'm going to be talking about Codable today. It is a bit of a deep dive, so it will get a little bit code heavy. Kind of a little bit about me getting started. I got my start as an iOS developer, a professional start at BMW in Greenville, South Carolina. And the 360 iDev Mini, they had two of them happen in Greenville. One of those was my first ever conference. And so this is a bit of a big deal for me coming full circle. I'm currently a software architect at Stable Kernel in Atlanta, and so kind of what that means is I'm involved in the second half of the sales process, kind of gathering requirements, scoping out work, and then the first half of a project where I kind of help get everything set up. And I'm doing a lot more kind of back-end and DevOps type work, but I do still get to poke around in iOS and web and Android from time to time. The reason I'm interested in Codable is I tried to write it myself not knowing that it was coming. So we had an internal framework that we use for building apps. I spent a fair amount of time trying to get it working for us for JSON, and then a week later Apple came out and obsoleted everything I had done. But it was interesting to see how they had solved the same sort of problems that I tried to solve, and our needs were a little bit different than general needs, so I kind of poked around and found ways to extend Codable to do things that we needed as well. And so it's kind of been my own little pet project for a while now. I have a son who turns 2 tomorrow, so my hobbies outside of work include things like going to the zoo. That's pretty much what I do outside of work. And I'm going to apologize in advance. I've got a couple windows, so we will have code. I've got it kind of step through and Git, and I'm just bad at window management. I've been practicing. I hope I don't make anyone dizzy other than myself. A little bit about Stable Kernel, where I work. We're a software consultancy in Atlanta. We're founded by Joe Conway, who is the author of the Big Nerd Ranch iOS books. And kind of before he started Stable Kernel, he also got to do a lot of teaching there at big places even like Apple, IBM, and Facebook. And so not only is our company very developer focused, but we're also very focused on learning and sharing and teaching each other. We get to work for kind of a lot of big cross-platform projects, and we've been particularly focused on IoT lately. And so that's kind of why I've been able to move into a role like software architect. So getting into Codable, it's a standardized approach to data encoding and decoding in Swift. The Codable protocol itself is just a combination of two other protocols, Encodable and Decodable. And what these are really for is to convert data to and from your Swift model objects. One of the things I like the most about Codable is that it's agnostic to the type of data you're getting. A lot of the times in apps, we're mostly just using this for JSON, and that's typically the only place you need it. But I like its flexibility in that any time you need to convert data from outside your app into your model objects, Codable's usable for that. And I like the phrase, make the easy things easy and the hard things possible. I think this is something that Codable does particularly well. So getting into the easy things first, just basic usage. All you need to do is just declare conformance. So I've kind of got a playground here. I'm going to tempt the demo gods with not only live code, but also playgrounds. So we've got some JSON data here. If you're not familiar with it, looking at it as I am, we've kind of got an object here, and it's got 2 keys, name and speaker, and this is just data for this talk, something you might get from the 360 API, for example. And I'm just converting it to data here. We've made a Swift model object that kind of matches that structure. We've got a name that's a string and a speaker that's a string. And we just make it conform to Codable. And that's it. We're done. Thanks for coming. One caveat of this is that every property on that object has to also be codable, or if you only went with decodable, they'd all have to be decodable to get this for free out of the box. And if we wanted to actually take that data and create an object from it, we're going to make a JSON decoder. And this is one of the kind of free decoders that you're going to get from Apple. And we are going to just decode our talk type from that JSON data. And now's where we tempt the playground. And we're able to see that we did get our talk here. So the name and speaker both came through, and that's really how simple it can be for converting data that you're getting into your model objects. So say we've got another talk. I'm going to pick on my buddy Eric, who gave a talk yesterday that was excellent about ARKit and core location. So say we've got another talk here. We've got the name of the talk and the speaker, and we want to encode that to data. So it's going to look almost the same. We are going to make a JSON encoder, and we're going to encode the ARKit talk. And then just so we can look at it, I want to make a string from that as well. This will be harder to see in the back for sure, but you can see that it has given us a JSON string that has that same. So kind of right out of the box, real quick encoding and decoding of the different types. But most of our model objects aren't this simple. So say we've kind of got more of a, even this is still a small example, but we've got an ID now. It's optional. We might not have an ID yet if we haven't saved it to the back end. We still got name and speaker, but we're going to have start time and end time as well. And so you can see that structure up here in the JSON. I'm breaking out the decoder into its own line, and then we're doing that same decode function. And when we run this, we're going to get an error. It's probably hard to see in the back. I'm not sure making it bigger will make it any easier with it being down here anyway, but what we're going to see is a Swift decoding error. And Swift errors aren't great in general, I'm sure you found, but like this one, the decoding errors tend to give you enough information to kind of hunt it down. It tells us, hey, we were expecting a double, but we found string instead. And this is going to have a coding path for us in there, and it's looking like it's start time. So this JSON decoder is expecting a double instead of a string, but one of the things that you can also do with these decoders is set different decoding strategies so that you'll see that we've got date, data, and key. We need a data decoding strategy, and we're going to tell it that we're going to use the ISO 8601, which is what format they're in up there. And now if we run it, we're able to get our talk with those dates on there. So what this is doing under the hood for you to get this is it's generating a couple things on compilation. You're getting coding keys, which is what it uses to map those keys we have in our JSON to our model objects. For the Decodable protocol, we're going to have init from decoder, and that's just rules for taking the decoder and making your model object from it. And in reverse, we have encode to encoder. So if we were to do everything we just did manually, you can see that we're going to make this coding keys enum here. It's a string-backed enum that conforms to coding key. And we've got a case for each of our properties there. In init from decoder, we're going to create this container keyed by those coding keys. So what this gives you is a type-safe way of accessing information in your container. And then for the one optional property we have, you'll see this decode if present function. We tell it what type we want and what key we want to use. For all the other ones, we're able to just do regular decode because they're non-optional, and we tell it what type we need. Looking at encode, it's almost the exact same thing. We're going to make a container keyed by our coding keys and encode all those properties. So you can see just kind of how boilerplate and tedious this is and why it's able to generate it for you off the bat. So because we're using the exact same keys for our properties that we get here, the coding keys are easy to make. These are almost the exact same line of code in each one, except for checking whether they're optional or not and what their types are. And then same for encoder. Looking at the JSON encoder, it has a similar date encoding strategy. And so it all kind of works the same. But this is what Codable's giving you for free out the gate when you just make your model object. So kind of stepping through what some of these things are. A decoder is any type that, or is a type that can decode values from a native format into in-memory representations. One of the things that I found confusing that other people tend to find confusing is that JSON decoder is not a decoder. What the JSON decoder is, Apple tends to call these top-level decoders or encoders. I like to think of them as formats. These are rules for how they create an actual decoder. So that's where we had our date or key encoding strategy. That's all at that top-level decoder like JSON decoder. But once we have a decoder, it's going to actually be attached to a particular bit of data that we have. And in addition to that, it'll have some metadata about the decoder itself and a coding path, which I'll get into a little bit more in a second. And one of the main things that a decoder can do is create different types of containers. So the one we were just looking at for our model object was a keyed container. It's just got keys and values, think like a dictionary. The other types, there's unkeyed that does not have keys, but it just has a group of values, so think like an array or a set. We don't have keys for them, but there are many of them. And then a single value container is what it sounds like. It's just a wrapper around a single particular value. And all these containers do similar things in decoding values into your Swift type. So that's kind of a lot to take in, and it sounds pretty boring, if not, like tedious. And so I find that kind of visualizing that helps me think about it. So say that this is information that we're getting back from the 360 API. We've got my talk and Eric's talk here, and this is what's coming back. At the top level here, we've got an array. So I'm just going to kind of highlight the whole thing with the blue screen of death. And this would be an unkeyed container because it's an array. And then the thing I've got over there underneath it is just an empty array, and that's its coding path. So since this is the very top of our kind of tree of data, it doesn't have a coding path. But then if we come in here to the first talk, you see that this one, like a dictionary, has keys and values. That's going to be a keyed container, but now it has a coding path of 0 because it was the 0th element in that array. If we continue kind of stepping through this tree, if we take the name of the talk, that one's just a string. It's going to be a single value container, and you can see its coding path keep getting longer as we go deeper. It's at 0 name. So that covers the 3 different types of containers, but also just on the structure you're getting, you might have nested containers in there as well. So we have another object in here for speaker. It's going to be a keyed container, and its coding path is at 0 speaker. And then it has single values in there as well. So the last name value would be a single value container. It's 0 speaker last name. We can have nested unkeyed containers. So we've got some tags about what this talk's about. And that's going to be an unkeyed container at 0 tags. And then values inside of there. Again, a single value container, 0 tags 1. And so these are all the different containers that we build, but decoders themselves kind of exist at one of these places in your code. And so that's why decoders have coding path to let you know how deep you are into the data and kind of where you're at. So I found kind of the easiest way to really have to touch every piece of it is if you have to write your own custom decoder. So the decoder I want to do for this one is going to be for an environment. So if you're doing like a Swift command line tool or server-side app, you've got access to these environment variables where you might want to store just different deployment configurations or something. And the way that gets represented in Swift is just a dictionary with string keys and string values. And so as such, it's got a flat structure, but when we're kind of parsing these, we might not want to keep that flat structure. And I'll dig into that a little bit more. So this is going to get a little bit too big for a playground. It was just not handling that very well. And so I'm going to show you just the main file of this command line. I've got this command line app. This is what the environment looks like here. We've got some different properties related to maybe a database connection. We have this API keys property that's got a couple different API keys, which really they're all just strings, but we've got that comma in there, so we want to interpret that as an array. And then for my command line app or backend app or whatever this is, I want to break that down into my configuration that I'm using throughout the app. And I don't want it to have that same flat structure. I don't want all these environment variables in the same place. So I'm going to start with an app configuration, and I want it to have a database configuration and also the API keys broken up into the array that I actually want to deal with them as. And so the database configuration, we've got all the properties for it. We had to do our own coding keys here because we don't want all our Swift properties in that horrible screaming snake case. But even though we made our own coding keys, we still get that default init from Decoder for free. So you can kind of break it up piecemeal as you need to do things differently. And so this is kind of what we're going for. The first piece we want to look at is the actual decoder protocol. A decoder itself can have user info, a coding path, and functions for creating the 3 different types of containers. And we're also, while we're doing this, we're going to look at the decoding error that we get from Swift. So this first class I've made, I'm calling an environment decoder. I'm going to hold on to the environment that I get passed in, but all the rest of it's part of the decoder protocol. So I've got my user info and coding path, and for now I'm just going to have those default to empty objects, so an empty dictionary for the user info and an empty coding path, since this will be our top level object. We've got this first keyed container function, and we're going to create an environment keyed decoding container. That's just one of the classes that I've got in this project, and we're going to pass along our environment, user info, and coding path. And when you're decoding, you kind of know the structure of the data already. And so in this case, we know that this environment's always going to be a dictionary. We don't need to handle arrays or individual values. And so for other 2 properties, we're going to throw a decoding error, similar to the one we got earlier when it expected a double and got a string. I'm going to do a type mismatch error. You tell it what type it was hoping for and build a context that's just a nested struct in decoding error. We're going to pass along the coding path, so the same way from earlier we wanted to see, hey, where's this problem happening? It'll give you the full coding path, and then we give a debug description to help hunt that down. Single value container, exact same thing, except for we're expecting a string instead of an array here. The one other decoder we know we're going to need, since we're going to be stepping through these individual string values, I'm calling a string value decoder. We're going to hold on to its value, which is an optional string because we either might not have the key or it might have just been an empty string with no value. We don't need to give defaults for user and for our coding path because we're going to be creating this ourselves internally, so we'll make sure we've already got these. And then for this one, we know that we can't have an environment because we're looking at a single value, so we throw a type mismatch decoding error here. And then for unkeyed container and single value container, we just create the appropriate container. You'll see the same thing, we're just passing along value, user info, and coding path. So the first container I want to get into is the single value container because it's the simplest. It has a coding path, and then various methods for decoding a lot of different types. So we've got nil, bool, string, pretty much any type of number you're going to get in Swift, including like 5 different variations of both integer and unsigned integer. And then the most interesting one is the one down here at the bottom of decoding any type that is decodable. So that's kind of where we're going to end up doing most of our work. So for this string single value container, I want to hold on to the value I got. Even though it doesn't need a user information or a user info, I want to hold on to that, and you'll see why pretty shortly. And then I've got one convenience function here to where I want to take a function that takes a string and returns an optional t. And then what I want to do is just kind of put all my error handling in the same place. If I don't have a value or it's an empty string, I want to just tell them, hey, this value wasn't here and we were expecting it. And then we're going to call that transform function on it, and if that returns nil, we're going to tell it, hey, we were expecting whatever the type t was, but we actually got, and then we can pass that value along. So hopefully this will make sense once we actually get into it. So for decoding nil, we just want to see if that one environment variable is either not there or if it's an empty string. All the rest of these, I'm going to be able to just use that unwrap convenience. So I want to try to cast it to a bool and unwrap it. It's already a string, so I can just pass it straight along. And then it's pretty much the exact same thing for every single one of these types. So Codable, all the Codable stuff definitely cheats toward being extremely tedious and boilerplate on the inside to make it easier to use on the outside. So I know that there's a whole lot going on, but I promise it's going to get so tedious that you'll definitely understand it. So we're doing this for pretty much every single number type as well. We're just trying to cast and then unwrapping it. And then here at the bottom, this is where we need to do our decode a generic type t. And the only thing that we know a decodable can do is initialize itself from a decoder. So we need a way of taking this value that we already have and making a decoder from it. And so that goes back to that string value decoder we already made in advance to prepare for it. And this is why I was holding on to user info, because the decoder will need that. So all we need to do is create that decoder passing along the value, user info, and coding path. and then we call try init from decoder on the T, and we're able to return that type. So looking at an unkeyed decoding container, we've got a few new properties up here that are all kind of involved with managing collections. We want to know what is our current index, what's the count, how many things does it have, and is it at the end. So we just want to decode objects off of it until it tells us there aren't any more. We've got the same decode methods, nil, all the other different types, the generic type, and then we've got a few new ones down here as well. So kind of when we were stepping through our data at the beginning, we saw that we could have nested containers, or nested keyed containers, nested unkeyed containers. There's also one called super decoder, to where if you're doing inheritance with your objects and you've maybe got your superclass information in a different place, it's just a way of letting you kind of be a little bit flexible with how you deal with superclasses. I've never used it and I've never seen it used, but if you get in a weird spot, just know that it's there. So for unkeyed container, we're going to be doing about the same thing. I want to hold on to this initial value that I got, but when I initialize it, I'm also going to separate them by comma, and this is kind of getting into the specifics for what we're trying to do with environment. We just want to take that string, and if it has commas and we want to treat it as an unkeyed container, go ahead and split that string by commas, and we're holding on to user info encoding path. I've got my one convenience function for this one as well, which is I'm going to call next, and I want it to give me a single value container for my next value. So I'm going to get the value from the current index and the values property that I'm holding on to. What I want to do is help keep track of coding paths so that we can give good errors and make sure that when someone's looking at a decoder, they know where they are in the tree. Because this is an array, I do want to pass in that current index, but int itself is not a coding key. So you see I've made this int coding key property here. You get a lot of it for free if you do it as a string-backed enum like we saw in the previous example, but if you want to make your own from scratch, it's pretty easy. It has a string value, an int value, and initializers for each of those. So I made my own initializer because I don't want it to be an optional one. I know if I have an int, we're good to go, but that's really all that it takes to write your own coding key that's not an enum. So I'm going to make a coding key for that index, add it to my current coding path, and then create a new single value container with the value user info in the new path, bump my current index, and then return that container. So this is going to be even more boilerplate than the other ones. You can see that for all of these, we're able to just return information about our underlying values array, where at the end, if our current index is past the end of that array. Decode nil has a little bit going on because the only way that you can decode nil for this is if the value we got passed was nil. Otherwise, we're going to throw an error here. But for all these other decoding functions, we're able to just create our single value container and just reuse all the work we did to where it's not just similar like the last one. These are all the exact same line of code, but we're just passing a different type into it. The only place this could get interesting is going to be in these nested containers. But in our case, for the environment, we can't have an object nested inside an array. So we get to cheat a little bit here and throw type mismatch errors for these, but we will get to those for the keyed container, so you can see kind of how those look. And for super decoder, I don't want to do anything different, so I just create a new decoder that has my same initial value and return that. So then the last decoding container is a keyed decoding container. The one you make will have to conform to the keyed decoding container protocol, which has a type alias. So it is one of those protocols with associated type, which means it's a pain to work with. So we have coding path. Again, we have a couple of functions here that deal with the fact that it's got keys, so we want to know all of the different keys it has. And you can also ask it, does it contain a particular key? We've got all the same functions again: decode nil, decode all the different types, decode a generic type, nested container, unkeyed container, nested keyed container, super decoder, and then you can also pass it a specific key that you want to use to get the super information out of it. So hopefully this is starting to feel kind of tedious now for everybody too. We're going to hold on to our environment, hold on to our user info. I'm going to make a convenience that will get me a single value container for a particular key. All we need to do to that is, since we did see that coding key has a string value property, we can use that to access our environment, which is a string-to-string dictionary. Oops, got some spacing issues there. Pass along the user info and then pass along the coding key, but in this case we don't need to make one because they've given it to us. We're able to just kind of bump that coding path and keep going. To get all the keys that we have, we're going to use, we don't know what the coding key is, but we know that it's got init from string value, which returns optional. So we're just going to compact map all of our keys through the coding key initializer that we get. Kind of in reverse, if we want to check if a key exists, we just see if our environment keys contains the string value of the key that they passed in. Again, this one's going to be using essentially the same function in every single place. Give me the container for this key, and then decode nil. And then decode each different type we get, same thing every function. This will get a little bit interesting for us when we get to decoding the generic one, but I'll come right back to that. And this is how we can do a nested container. So mentioning that the key decoding container protocol is a protocol with associated type, it's hard to just create one. And so you can use this initializer for key decoding container, and you pass it anything that conforms to the key decoding container protocol, which is what ours is. And then we just pass that along. But that's why there's kind of one extra hoop here for this one. For nested unkeyed container, that's quite a bit easier. We just make our container, pass in the value at that key, and then bump the coding path. Super decoder, we just pass along our original decoder so that it's treated in the same way. And so kind of this is where our environment calls for a bit different situation. Since we are trying to take that flat structure and break it out, what we're going to do here is when someone asks us for a value for a key, or a type that's decodable for a key, we want to check to see if we have that key. And if we do, we know we've got a string value there. We're going to make a string value decoder, again, taking the value out of the environment we have, bumping the coding path, and then trying to create our T from that decoder. But instead of throwing if we don't have that key, we're going to assume that they just want a nested object. And instead of saying, hey, we don't have this key, we're just going to give them another environment decoder with the exact same environment. And so the way this ends up looking, if you saw earlier when I came in here, I've got this database key. It doesn't matter what this is. I just need it to miss so that I can have that nested object. That's kind of where I've got some hackery, I guess, in this decoder that I'm writing. So we're going to create an environment decoder ourselves from the environment we pulled out of the process info, and then we're going to try to create it and then print it. When actually running something like this from Xcode, you probably can't see it in the back, but if you edit the scheme you're running, they've got a place for you to put all of your environment variables that you want to run. So this just matches that comment I had at the top of the file. When we run this, hopefully you can see that we do have a successfully decoded app configuration. It's got a database configuration there. It has all of our different database properties that we put in there, and it has properly split our API keys. So that's kind of every piece there is to decoding. It's all exposed to where you can make tweaks to where even if we're making like special decisions about how we want to handle something, we just go to the one place that's done and we can do it. One thing we didn't really touch, I just made an empty user info at the beginning and continued to pass it along. This is a place where you can pass information that an object might want from the decoder itself. It's just a raw representable with a string value underneath it. If you've worked with Notification Center the same way that you might want to create your own static property on notification.name, you can just create your own coding user info key. And one of the places you can use this is try to decode types differently depending on what's come in. So maybe you have like, I need to handle this model object differently if it's coming from the database versus if it's coming from JSON API or something like that. So the first thing I'm doing here is just extending that coding info user key. I've got two properties that I'm going to pull out of that same process info where I got the environment to get the name of the process that's running and get a PID for it. And so you see here I'm just creating a coding info user key with a raw value of just something that's namespaced enough that I'm not worried about collisions really. I'm going to make a few tweaks to my environment decoder. So I'm going to make an initializer that just takes the 3 values like it did before, but I'm also going to make another one that you can just create from a process info that defaults to the singleton that you get, so that you can just create an environment decoder and have all this information. I'm going to pull my environment out of the process info. I'm sorry, I don't think I actually need these since this is part of what you get for having that type safety. So I'm going to say my user info is going to be process name, and then pull the process name off of that info we got. Same with the process identifier, and then we know that our coding path is going to be just an empty array. And where we can do different things with that, so say our database configuration, maybe for one particular app we want to use different environment variables than another. So now I'm going to get away from the kind of free coding keys we have, and I'm going to make my example coding keys that keep using that DB underscore name of the property, but maybe if I'm running something else instead of DB, they come through as database. And so I want to have my model object be the same when I get it, but I want to handle those different decoding processes. So now because of this, I'm going to have to write my own custom init from decoder. And what I want to do is I want to get the process name. I don't need those either. That should help a little bit. So I'm going to access the decoder's user info and try to get the process info and process identifier as the types that I think they are. I'm going to print out what those are, but then here's why I want to do things a little bit differently. So if the process name that I get is example app, I'm going to make a container for my example coding keys and then decode each of those. But if it's anything else, I want to make my container using the other coding keys. You see now I don't need to pass anything into the environment decoder because it gets it on its own. So I'm not sure if you can see that, but now that we're decoding, we're able to get the process ID for what Xcode was just running. We can see that it was in fact example app, which is good because that's what our environment variables matched, and it was able to decode it properly. So encoding is almost identical to decoding, like it's pretty much the same stuff over and over and over again. There's a little bit difference in naming. Decoder becomes encoder, decoding error becomes encoding error. All these other long, tedious, hard to say properties all just replace decoding with encoding. They have user info encoding path in the same way. And there's just a few subtle differences that we get. So for one, when you're encoding things, you're kind of defining the structure as you go, so all these container functions don't throw. If you want to put a keyed container there, that's fine. Unkeyed, that's fine. Whereas the decoding ones all have to throw because you could be looking at the wrong structure. Encode functions are all mutating because you're holding on to this data and mutating it. There's another property or function that I never see used, but it's worth calling out in case it hits one of your edge cases. There's something called encode conditional. So if you encode something that's a reference, it will check to see if that reference is already there or not, so that you're not duplicating, I guess, references to different things. But again, that's something I've never seen used. And unkeyed container doesn't manage whether it's at the end or not. You just encode objects to it until you're done, and that's it. So kind of seeing how that all works under the hood, a lot of the times with your model objects, you're just making them from the keyed containers. But there are times when you might want to do something from a single value or an unkeyed. So I want to get into those a little bit as well. Going back to the playground for this one. So we're kind of back to this early talk data structure. We've just trimmed it down a little bit. But let's say that we want to make our identifier a little bit more type safe. So we don't want to accidentally call talk by ID with a speaker ID. So we're going to make this struct inside of our talk that's an identifier, and it's got a value. But since this is a kind of another object inside of it, if we were just doing this in JSON, this thing here would need to be an object, which we don't want. But we also don't want to have to do all the decoding manually just because we have one property that's different. And so what I'm going to do instead, so you'll see I've got my identifier here instead of an int. I'm going to make identifier itself codable so that we can just work in there. And so to kind of flatten this out, instead of doing a keyed container, we're going to access the single value container that we just saw we're making, and then we can just decode an int off of it. Again, encoding almost identical, except for we're mutating, so we need our container to be a var. We make a single value container, and then we encode that value to it. It's a little more contrived example. I'm going to try to force, maybe you're making your own collection for the tags. So for some reason, set and array just doesn't work, and we need a special tags struct to manage this for us. Under the hood, I'm just going to use a set to kind of make it make sense, but again, in this one, we're going to want to use an unkeyed container instead, because we know we might have many tags. We're going to make our set an empty set, and then as long as the container's not at the end, we're going to try to decode a string out of it and then insert it into our set. Encoder in this case is a little bit easy. We just make the unkeyed container, and for each item in the set, we encode it. So this is how you can kind of work with anything that's not a regular object, and hopefully that makes a little bit more sense after stepping through what it takes to kind of support this from the decoder side. So Foundation already has encoders and decoders for both JSON and property lists, which meets most of the needs that you're probably going to have in an app. But it is data agnostic, so you never know when you're going to get put in a place to where you're stuck dealing with SOAP and XML, to where instead of kind of having to write this whole thing every single time you get stuck with XML, you could write an XML decoder and encoder, and then you've got that for use forever. Protocol buffers are seeing more and more use where you kind of define your own data structure. You could make encoders and decoders for that. Anybody using Cloud Kits probably had to write the same kind of boilerplate information to convert a CK record to their model object and back. I think that's actually a great use for that, and I'm going to push out a blog post to our company blog next week on doing that for a CK record. So thank you for coming out. I do have a link to the blog up here. I've pushed all the different code up to GitHub, so that's github.com, Marcus Smith Codable Talk, and a little bit of pitch about our company. Oh, sorry, people are still taking pictures. We are hiring at Stable Kernel, so we're looking for people that like to try new things. A lot of us, myself included, came in just doing iOS, and since even the last couple of years I've been able to do web, backend, a little bit of Android, DevOps. And so if you're looking for a job and want to move to Atlanta, or if you're already there and like learning new things, we'd love to have you. We're also raffling AirPods and an Apple TV at our booth, so swing by and say hi to Aaron. And I'm not sure if anybody has any questions or.
Have you ever worked with JSON, which was like JSON but with references, so you have A pointing to B, B pointing back to A?
I haven't used that one now.
But I was wondering if you could use Codable or Codable for that.
I think you could if you knew what the rules were for it. So if you've got like IDs for the object, you could hold on to like what IDs have I already seen. Okay, I can create a reference there instead. All right, well, thank you very much.